Hi and Assalamualaikum. My name is Muhammad Kamil Isas bin Osman. In this video, our group will be presenting about our group project, which is the electronic piggy bank. Our system consists of three parts, which is authentication, 4-bit counter, and the clock disabler. For the authentication, we're going to input the password, which is a 2, 0, 0 and 2, and the output will be processed in the circuit, which is going to go through the AND gate, which is connected to the high input. This high input is the batteries, and it goes through the 4 to 16 decoder, and if we input the correct password, the green LED will light up, but if we input the wrong password, the buzzer will make the sound "sorry, please try again," and the red LED will light up. If it is in default state, which is 0, 0 and 0, both of the LED will not light up, and if we input the correct password, it will go to the AND gate, to the green LED, and it will go to the clock disabler. And that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Mustafa. I'm from Group 6. Today I'm going to explain the clock disabler in our mini project. So first thing, the clock disabler is joined with the input gates from the green light, from the green LED, from the green LED here, going like this. It's connected to the clock disabler. So when the clock disabler receives a count of 0, it will stop the input and move the output to the clock generator. So the clock generator can move it to the counter. Thank you for listening and have a nice day.
Hi, Dr. I'm Gilawi and I am from Grade 6. Next, I would like to present the 4-bit counter. As Amma mentioned before, we can see that the clock disabler will disable the counter if it receives 0, which is low as an input. And we can see that our outputs of clock disabler are actually connected to all clock inputs in the counter. Next, our all present inputs in the counter are connected to 1, and our kill inputs are connected to kill switch. For flip-flop 0, we can see that our both J0 and K0 are connected to 1, which is high input. And for flip-flop 1, we can see that our J1 is actually connected to here Q0 and also Q3 prime. And our K1 is actually connected to Q0. For flip-flop 2, we can see that our both J2 and K2 are actually connected to our Q1 and here, which is Q0. Next, for flip-flop 3, we can see that our J3 is actually connected to here, which is Q2, and here, which is Q1 and Q0. And our K3 is actually connected to here, which is Q0.
Hi, my name is Leka, so I'm going to continue for the further explanation of the chip for the 4-bit counter. So I'm going to explain about how the timer is gonna go to 0 again with the clear switch. So this clear switch will be connected to the all CL clear input in the counter at each JK flip-flop. So this switch is to avoid any bug or problem, which the user can toggle this switch twice to reset or disable the timer. So if the timer goes, for example, I'm going to activate this, and then the timer is 3 seconds, right? And then if I toggle this clear switch to 0, the timer will go 0 again. So this clear switch reset the timer to 0. So this timer is used 7-bit segment display, which connected to the output from the counter, which is the LSB input is connected to the Q0 output. Next input is connected to the Q1 output, and the following input will be connected to the Q2 output, and the MSB input will be connected to the Q3 output. That's all from me. Thank you.